In this video, I'm going to introduce you to Visual Logic, and it's just an overview. Hopefully you've already looked at the video that shows you how to set up your USB drive with appropriate directories and how to download Visual Logic and all that. If not, you need to go watch that first because that's sort of the predecessor to this. Anyway, let's go ahead, assuming that's the case, and open up File Explorer, and we'll locate our device. Mine's removable disk G, yours could be something else, Cruiser A or F or whatever. Here's 150 directory we've already created and Visual Logic. Now, you always have to start the Visual Logic exe before you open up any file. It's just the way it's set up. You don't have a registry entry because it's not installed in the operating system. And it doesn't work if you try to map it to that. That's not going to work either. So, let's go ahead and start that up. And as you'll see, you get this little splash or nag screen as they call it. And we want to click the continue button. Browse to my VLSig file. This you should have already gotten by watching setting up your USB drive for CIS-150. We went through how to register the product, and I explained to you that there's a .vlsig file with your name on it that they email to you as an attachment, and it has to be downloaded into this directory. As you can see, I've got mine here. So I want to find that. Pull this over here where you can see it. And there it is. Then it asks me if this is who I am. Of course, that's who I am. And I get this basic screen. Now, this is an empty Visual Logic file. Nothing's been done to it. It's brand new. As you can see, it says new program. That means we've not saved it. So let's go ahead and do that. Always get in the habit of saving your work when you begin. And then after you do a few things, always save it. Control S is a shortcut for save. Once you save it and tell it where to put it, just Control S every few minutes, and you will not regret it. Alright, let's find there's my directory. Let's just pretend for discussion purposes that this is an in-class lab. Let's call this, create a new folder, in-class lab 0. So that'll just be a little test for us. You won't have to turn this in or anything. Alright, so I'm going to go down inside of that. Now I'm inside my in-class lab 0. You have to understand how these files work. If you don't, you need to get up to speed on that. I'm going to call this in-class lab 0. There is no in-class lab 0, so I can delete this without any problem. Now, notice that I have a name up here. Okay, that's good. Now, if you haven't thought about this, when we start doing flowcharts and pseudocode, we always start with a begin and end or start and stop, and that represents the program beginning, being loaded into memory, and then executing through, and then ending. Now, I want to sort of emphasize something here and exhort you to remember this, because you will be on my good side if you do and converse with that if you don't. This is a design tool. In Visual Logic, you do strictly program design. That comes after the logical design, which is really the meat of the course. You should already have the logical design done for a program before you get here. Don't get into this program and start trying to design it here. This is not the place for it. If you need help, I'd be glad to help you. But if you raise your hand and I ask you where your logical design is and you don't have one, you're not going to get any help, because you should not have gotten here to start with without that. Okay, and that'll become clear as we go along. Obviously, this is just a primer for Visual Logic. But I want to plant that seed because people have a tendency, and I think it's human nature, to want to just do the problem, get it over with. Here's the issue. When you think you understand the problem, you probably really don't understand the problem. And you're going to be going back and adding stuff, deleting stuff, and changing things. That is where the logical design comes in. That's where you do that kind of stuff. You try to eliminate logical errors in the logical design. In fact, 70% of your effort should be put into logical design using flowcharts and pseudocode before you ever get here. Now you got to keep that in mind. That's a temptation you're going to have to fight, because we all have it. All right. Let's say that I've already got a logical design done, and I want to kind of just explain to you a little bit about Visual Logic. Okay, if you'll notice here, we have a begin and end, start and stop, and a little connector. If you right-click on that connector, you'll see all sorts of logical constructs here, right? You have an input statement. Now, again, you probably haven't gone into the course enough to know this. Perhaps you have. That's fine. You have an input, which takes input from some location and stores it. An assignment statement, which if you looked at variables in it all, I've told you about that, what an assignment statement is. and output. Now that's an if, loops, and there's an array, and there's procedures and so forth. That comes later in the course. What I'm going to do here is I'm going to set up this little program, what we call the Hello World program, and it's going to create a variable and assign it a value and then output it to the screen. Okay, so I've already got the logical design done for this one, so I'm just going to go ahead and create my variable, and I'm going to use an assignment statement for that. Now there actually later on we'll get into actually giving them data types, but just for now this will be sufficient. Notice I've got the variable and the expression. All right, the variable is the name of the variable that points to the memory location that's going to be allocated by this program in conjunction with the operating system. Again, I've already had a video on that, so if you haven't done that, you need to look at it. Okay. All right, so I'm going to call this variable phrase. Okay, that's the name of it. Notice it's all one word, so it's all lowercase. Remember camel casing, that's in the video too. You might want to go look at that or in the textbook. This is of type string, so guess what? The characters I'm going to put in this string are going to have to be delineated with opening and closing quotes or wrapped with those. That tells the compiler this is a string literal. Now this is what I want to store there. Hello world, that's what I want to output. Okay, see that? So that's the variable, and this is the assignment statement. What happens is it's going to create, when it sees this, the compiler is going to create a variable of type string called phrase. Right? It's going to create a big enough memory location to hold that string, and then it's going to assign the string literal into the memory location pointed to by phrase. All right? Now again, you can look at variable, the video associated with that, and this will be further explained. So again, you should have already seen that. So okay, now I've got my assignment, and I want to do an output. Now there's a couple different types of problems you can face with Visual Logic, some of which I won't get into now. But two of which I will, because you'll see this quite a lot. And these are like little syntax errors. The difference between a syntax and logic error, if you don't already know, is syntax is just a mistake in the language. Most compilers will catch you on that, and so will Visual Logic most of the time. It'll pop up the red box from Hades showing you all these different errors and popping up and doing all kind of crazy stuff. So it'll let you know. Logic errors, compiler doesn't care about those. If you meant to divide 10 by 5 and you put in 10 divided by 4, it doesn't care. It's a valid statement. It's just the result won't be right. That's a logic error. That's an unintended consequence of your design. That's what we're trying to eliminate, the latter, the logic errors. By doing the logical design first, then coming in here, we'll have a product that's pretty well debugged before we ever get here, okay? All right, so now we need to do output. Again, we'll get into all this much later. This is just a little primer on Visual Logic, and I grab the shape I want, and I'm going to use dialog boxes pretty much. So my output's going to consist of my phrase is, right, space, ampersand, and now I've misspelled that variable on purpose to sort of explain a couple things. One is variables are case sensitive in most languages. So phase is a different variable than phrase, okay? The difference is in most compilers, true compilers, they won't let you make that mistake. When it sees phase, it's basically going to let the programmer know, I don't know what this is, it's undeclared, error, you got to fix it. Not so in Visual Logic. It will let you do that because it's sort of like Visual Basic 1.0. It's a knockoff of that, I like to call it. Because in that language back then, you could declare a variable on the fly without ever actually giving it a declaration statement. You just type it in, it sees it, says, oh, here's a new variable, I'll set it equal to 0 and we'll use it. That's exactly what happens here. Now watch. Okay, I've got my, let's go ahead and save it. I'm going to press Control S, or you can click on the little disk here. Now, to actually run the program, you can press F5, or you can come up here to debug and run continue. F5 is the same thing. So I'm going to press F5. Look what it did. It said my phrase is 0. Why did it do that? When phrase has hello world, because it saw a misspelled variable here, thought you wanted to create a new one because it hadn't seen it before, and gave it a default initialization of 0. So if you see something like this, you need to go back and check your spelling, because chances are you've misspelled something. All right? Now I've got phrase here. I'm going to change it and make it correct. P-H-R-A-S-E. All right. F5. My phrase is hello world. Now my monitor's a little bit screwy, so it's chopping off some of the bottom of the characters. Yours probably won't be that way. So what I did was I had a string literal, and I joined it in with this string and output it to the screen. My phrase is hello world. Now, remember I said that in some of the other videos dealing with strings and all that, I told you that if you have a string literal, it has to be wrapped, delineated with opening and closing quotes. If you miss one, here's what will happen. It's going to throw the red box from Hades. Oop, got an email. And you're not going to like it. See that? Execution error, blah, blah, blah. Well, you get all that. And chances are, when you see that, you forgot an opening or a closing quote. Just a little tidbit of knowledge here for you. 2 things to look out for. That's not all of it, but that's that you'll run into this more than anything else. Let's see. I think that pretty much gets us down the road as far as we want to go. We can save this, and then we're done with our little program.